Continue our discussion about simplifying radicals with variables. We see that we want to find the pair of numbers or variables in this case that are the same that we can pull out of the radical, because we can show that if we have a pair of numbers, we can pull them out of the radical. So really taking the square root of radicals with variables of any exponent is pretty simple once you know how to break down that exponent into multiplication. So if we were given an example, let's just go with the square root of x. Nothing times itself is ever going to give us x. If we were ever to factor x, well, it's really just 1 times whatever x is. So we really can't simplify this. We would just kind of have to leave it as square root x. But if we were looking at x squared, well, we know, and we just did this example, x squared is the same thing as x times x. We can find that pair, pull it out, and we know we're just left with x. If we were looking at x third, that's the same thing as x times x times x. Well, we only see one pair that we can pull out of the radical. So then we're left with x times root x. I know that it may seem a jump to go from x cubed to x times the square root of x. But what we want to show is that if we're taking the square root of x to the third, we're looking for what times itself equals x to the third. Well, we know that somewhere within here is x to the second power times x. So x to the second power has a square root of x, and we can't do anything with that leftover x, so we leave it under the radical. If you were in math support, you've done this a lot, where you've just written out exactly what the exponent means. So in this case, x to the fourth is x times x times x. And we did this a little while ago. Here we can pull out 2 pairs of x from underneath the radical, and x times x is x squared. Just to keep going, x to the fifth is x times x times x times x. We can pull out 2 pairs. We'll just have to leave this one x under the radical. And since we pulled out 2 pairs, we pulled out x squared. Let's see, x to the 6th power is x times x times x times x times x times x. And we can pull out 3 pairs here. Hopefully we're starting to see a pattern with how we pull out pairs of variables and then what we're left with afterwards. So let's do x to the 7th, and then we can look for that pattern. That's 4, 5, 6, 7. Okay, and we see 1, 2, 3 pairs. Sort of like the last time, but now we're left with an x. So we have x cubed because we pulled out 3 pairs, and then 1 x left under the radical. So as we see up here, the square root of x, we just have to leave as x. Nothing times itself equals x. X squared, there we go, started writing too early. Square root of x squared is just x. Square root of x cubed, well, that's x times root x. We got that from doing this here. X to the 4th is x squared. Root x to the 5th is x times x squared. So I hope you're starting to see a pattern. Often in support, we'll talk about how you can just take the exponent underneath the radical and divide it by 2 and take the radical away. That could be a way that you could think about this. That should be a 3. Doesn't look like 3 though. So as long as we can take the square root of one variable, no matter the exponent, we can start to talk about taking the square root of multiple variables under the radical. So here's an example. X squared times y. Now, we already know what the square root of x squared is, and our really awesome law of radicals tells us that if we have any two things or three things being multiplied underneath a radical, we can write that as two separate radicals with the same things being multiplied. So we know that we can rewrite this as x squared times, root x squared times root y. Well, we know that there are two pairs of x under here, so we can pull them out of the radical and just call that x. And we can't really do anything with the square root of y. Nothing times itself will give us y. So we're done. Let's try another example. X times root 10. Well, we saw over here when we were taking all of the square roots that there's kind of a pattern of taking the exponent and dividing it by 2 if it's even. So whereas we had root x squared, we can just call it x to the 1. Root x to the 4th, we can just call it x to the 2nd power. Root x to the 6th, we can just call it root to the 3rd power. So I want to show with x10, x to the 10th power, we can rewrite that as x times x times x. That's 3, 4, 5, 6, 7, 8, 9, 10. And we see 5 pairs within here. So when we pull out those pairs, we have x to the 5th. Okay, one more example. Y squared times z to the 5th power. So because of our exponent law, we know that we can write this as y squared times z to the 5th power. So anything squared under the radical is just that anything. Y times y will give us y squared. So if we take the square root of y squared, we know it was y. Y got us that y squared. So we know our answer there is y. Now we see 5 z's underneath this radical. If I was going to draw this out a little bit more, it'd be z times z times z times z times z. We can pull out 2 pairs of z's and leave 1 z underneath the radical. So that would be z squared times root z. And so our answer, if we wanted to write it more condensedly, would be y times z squared with 1 z left under the radical. And what's going on is multiplication. It's multiplying y times z squared times root z. That's all that I have for you for multiplying variables underneath the radical and simplifying that square root. So for now, we can do that, and we're going to work towards our goal of simplifying something like this in our next video.